Hello, can you please confirm if I'm audible? Hello. Okay, fine. We'll start in 1 or 2 minutes. We'll wait for some more participants and then we'll start. Yes, so, fine, let's start today's session. So, I'm Anand Singhal, a PhD student from IIT Jodhpur. I'll be assisting in solving similar assignment problems for the course Digital Electronic Circuits, which is taught by Professor Gautam Saab from IIT Kharagpur. And today we are taking week 5 live session that will be similar to the problem for assignment 5. So till now, this is a course outline, and till now we have covered the initial 4 weeks, which has covered the basics of devices, then the basics of basic gates and all the logic functions and K-maps, and then we did some minimization problems and hazard problem in week 3. In the last week, we read about certain circuits such as multiplexers and parity generator, etc. And in this lecture, we'll be studying about the basic Boolean algebra or the basic building block of any digital circuit, that is the number systems, in which we'll be studying about certain different bases, that is octal, hexadecimal, etc., and some binary arithmetic, what is ones and twos complement, and some of the circuits that are left in the last lecture, that are adder and subtractor. So we will be seeing some basic questions on them also, and till week 6 we will be completing the combinational part, and in the from the week 7 we'll be starting our sequential circuit part, which is the most important part in this particular course. So let's start. So before starting, there was a question in the previous week assignment, I guess, for the multiplexer problem, which was quite good, and I did not get the time to solve this particular question. So I will be solving this question once, and after that we'll be starting with the topic of this week's. So let's start with this question only. So it says it is, I guess, given in the assignment problem also. I'm not sure about that, but I guess it is given. So it says the following circuit diagram: the propagation delay of a multiplexer, NOR gate, and the inverter are 1 nanosecond, 1.5, and zero point 0.5 respectively. So I'll write it. It says the propagation delay for the multiplexer. I'm writing it in mux. It is 1 nanoseconds. For NOR gate, it is 1.5 nanoseconds, and lastly for inverter, or I'm writing not, it is 0 0.5 nanoseconds. Yeah, and we need if P, Q, R, S, T are the applied at the same time. So these 5 pulses are applied at the same time. So the question asks for the maximum possible propagation delay in nanosecond to the output Y. So as we know that this is a mux, and mux always depends upon the select line. It will choose a path accordingly on which select line it is working. So we can have two combinations here for select line 0, and there is a complement for select line 0 of this mux here. So we can have two combination. One will be when t is 0, then this select line will be 0 and this will be 1, and one is t is equals to 1, then this select line will be 1 and this will be 0. So let's see one by one what will be the path that will be followed for for the first case. So let's say I'm taking for t is equals to 0. So for t is equals to 0, this s naught will be 0 and this s naught for this mux will be 1. So since s naught is 0, so this part will be working. So like these are applied at the same instant, so the path will be followed by this mux and the output will go for 0 and then it will go. So since this select line is 1 now, so it will go to the 1 part and ultimately it will reach to y. So the purple ink will showing you the path which will be followed when t is equals to 0. Similarly, we can make the path for t is equals to 1 with the green ink. So when t is equals to 1, so when t is equals to 1, s naught for this particular mux will be 0. So since it is 1, so it now this path will be followed. It has started from this one. It will go to now since s naught will be 0, so it will go to this NOR gate now, and ultimately it will reach to the final output y. So there can be two possible combination to get the final answer of this mux. So we just need to calculate the total delay in both of these paths. So let's say I am defining them as 0 comma 1. So whatever will be the max of tau 0 or tau 1 will be giving me the final answer, because it is asking for the maximum possible delay. So let's calculate tau 0 first. Tau 0 means when t is equals to 0. So for t is equals to 0, we were using this purple ink. So using the same, when it is 0, so the first component is the NOR gate. The delay of NOR gate will be there. The delay of mux 1 will be there. So I have reached here, then there is no delay in this, and finally the delay of mux 2 will be there. So this will be the total delay for t0. Similarly for so let's calculate also. So NOR is 1.5, mux is 1 nanoseconds, and this is also 1 nanoseconds. So the total delay will be here as 3.5 nanoseconds, and there will be for 1 it will be, I'm using the green ink now, so it will be the NOT, and then it will be mux 1, then it will be NOR, and finally it will be mux 2. So again calculating the same, so it will be 0.5 plus 1 plus 1.5 plus 1. That will give me a total of 4 nanoseconds. So since we have arrived to a decision that the maximum propagation delay is asked, so either of them, the maximum of that is 4 nanoseconds. So for this particular question, answer will be 4 nanoseconds. Is it fine? Is there any doubt in this particular problem? Please respond in the chat box if you have any doubts. Right. So since this week is all about number systems, so there will be very easy questions to get to know about the number systems. So I'll give you maybe 2 minutes to solve each and every problem, and then I'll be solving the same. So let's start with the number system basics. Uh, so this is the first problem, which says if log to the base 2 5 and 12 is x, then we need to find the value of x. So you can take 2 minutes and let me know your answer, and then I'll solve the same. These are very basic problems initially, and then we'll go to some complex problem. So take 2 minutes and let me know what option are you getting. Okay, so we have our answer. Now it is a very basic question. For this, we need to know the basic properties of log. That is, I will write. Sorry, I will write all the properties of log. So if there are two variables that are getting multiplied, they will be getting split. The base will remain the same. Then log to the base a b raised to power c is c log, and finally if we have the similar base and similar variable inside, it is 1. So these are the basic properties that you need to know about this particular question, and now we'll do the question directly. So the question was log to the base 2 512, and we know that log to the base 2 512 is nothing but repeat it, 2 raised to power I guess 9. Now we have log to the base 2 2 raised to power 9. So I'll use a property that log to the base a b raised to power c is c log to the base a times b. So it will be 9 times log 2 to the base 2, and since we have the similar base, it is getting reduced to 1. So the final answer will be 9 only, which is option D. Option D is the correct answer. Is there any doubt? This is a very simplistic question. Any doubts? Please respond in the chat box. Fine. Mm, so now this is the question of basics, the base of the number systems. So maybe you can also try, because this is again the basic and it is also covered in one of the previous lectures also. So maybe you can take 2-3 minutes and then I'll solve the same. Okay, so I've got one answer, that is 6. So let's try the same. So we already know that any number, even if we are doing the binary part, so let's say 101 to the base 2, one of the major properties, the variable inside, that is these quantities, uh, I'm writing them as variable, should be always less than the base. So even if we have a base 2, we cannot even have a 2 inside. This is the one basic property, and the second is this is the this is the zeroth place, this is the first, and this is the second. So it always starts from base to the power 0 and it goes till base to power n. So whatever n will be there, n number of digits, will go to the highest power, and we will be starting from 0 to calculate the final decimal equivalent basically. So to calculate the same, let's do the same for this question. It is given the base is r and here the base is 5. So I'm calculating the RHS first because it is quite basic. So it is 203 to the base 5. So I can write this as 5 raised power 2. I can write this as 0, 5 raised power 1, and the final is 3, 5 raised power 0. So I'm writing this as 2 times 25, then this is 0, and finally it is 3. So it will give me 53. And we need to equate the same with a polynomial equation in the LHS. So let's calculate LHS, which is this. So again I'm doing 1 r square, then 2 times r raised power 1, and finally I have 5 r raised power 0. So this is r square plus 2r. Finally this is 5r. Sorry, not 5r, it is only 5. So equating the first and second equation, it is r square plus 2r plus 5. This is equals to 53. So r square plus 2r plus 5 minus 53 will give me 48. Factorizing these two numbers, it is 8 and 6, 8r minus 6r. So it will give me minus 6 and r plus 8. So we can have two possible values of r, that is 6 and minus 8. So a base cannot be in, first of all, in negative, so this cannot be the answer, and we need to check if it is following all the properties. So I have got r as 6, so all the variables are less than 6 first of all, and it is again following the equation which is going to the decimal equivalent. So the possible answer can only be r is equals to 6, which is also given by one of the students. So the final answer is option D. Is there any doubt? Fine, then we can proceed. So these are some convergence basic. So let's try to convert first of all this into decimal, and yeah, so let's try to convert all of them as decimal equivalent. So the question is, convert these to their decimal equivalents. Again, I have already told in the previous question how to do this basic thing. So let me know the answer quickly for both of the questions. You can take, maybe you can wait for hexadecimal if you don't know the concept, but try to do this. One more thing I like to add here is that since before the decimal place, what we were doing is we were starting with our 2 raised per 0 and we were going to 2 raised per n. So similarly here we start after decimal with 2 raised per minus 1, not with 0. So do keep in mind this thing, and we'll go from minus n, whatever the n number of digits there will be. So let me know the answer for this decimal equivalent in maybe 1 minute. You can take your time and then I'll solve. Okay. Which video link are you referring to? Video link. The YouTube link for week 4, are you asking? Can you please confirm which video link are you referring to? Whosoever has asked this, can you please confirm which video link? Is there any answer for the decimal equivalent? So let's try to solve it then. Now the question says, okay, I've got one answer which is 511.4. We'll see if this is correct. Okay, so let's try to calculate. So the first is 4021.2. So for point 2, to convert it into the decimal equivalent, I'm just writing 10 raised per minus 1 because, uh, sorry, it is base 5, so I have to write 5 raised per minus 1 instead of 10. That will give me 2 by 5, that is zero point 0.4. So after decimal, I will be getting a zero point 0.4, and before decimal, we need to check. So this is 4021. So I'm writing the same now. It is 0, 1, 2, 3. So 5 raised by 3 plus 2 raised times 5 plus 1 is only 1, that is 5 raised by 0. So this is 5 cube, that is 125 times 4 is 500 plus 10 plus 1. This is 511. So the first will be 511.4 to the base 10. I guess which is also given by some of the students. So yeah, that is correct. And similarly, we can convert. So in hexadecimal, we have a certain denotation that from 0 to 9, it is represented by the decimal places only. And then from 10 to 15, which is base minus 1, it is represented by certain alphabets that are A, B, C, D, E, F. So we can easily calculate this. So it is B times 16 raised power 3, then it is 6 times 16 square, 5 times 16, and finally we have F times 16 raised power 0. So B is, you can see it is 11, 16 cube, 6 times 16 square, then 5 times 16 is 80, and finally F we have 15. So we have got, I guess, okay, so we need to do the calculation here. So 16 cube is 96. So this will be some number. So after adding all this, I will be getting 46687. I guess, yeah. So is there any doubt? Please let me know if there is any doubt. Okay, fine. Okay, so these are again some basic questions. So there are two ways. First of all, let's stick to the basic. Don't go for decimal places for now because I need to tell few concept here. Uh, so it is saying that these are decimal numbers and you need to convert it to the given form. That is, you need to convert this to octal, you need to convert this to hexadecimal, and the final you need to convert to binary. So there are certain relation between all these three things. So just to simplify it, for now I'm not using these decimal digits. So you can take maybe 2-3 minutes and let me know the answer if you already know how to do that, and then we will try to solve the same. Also, Neetu, are you the one which I used to teach the gate?
Yes, sir.
Okay, so how was this gate exam? Yeah, was it fine?
So this year I didn't appear for the exam.
Okay, so you did not appear for the exam.
Yes.
Okay, fine. Yeah, all of you take your time and let me know the answer. Any answer for the first part? So I'm getting one answer is 16612. So this is for octal, I'm guessing. Fine. So let me try the first part then. So instead of like going from decimal to octal, there can be one method that doing the LCM part. So I'll directly let you know the easier method. The easier method, so it is valid for both octal and hexadecimal. So what we'll do is we'll first convert the given number, convert the given decimal number to its binary equivalent, and doing this we will be making pairs. Since it is for octal, we will be making the pairs in 3. For hexadecimal, we will be making the pairs in 4 because of the limit. So 3 pairs means 111 is the maximum limit, that is 7, and here it is 1111, that is 15. So we will make the pairs. It will be easier to explain by example that is given. So I'll be doing this, and this will give you the final octal representation. So I'm trying to do the same for the first part, that is 7562. So we will be going for the decimal conversion, sorry, for the binary conversion. So I'll be doing the division. So this is 3781. So the, I guess it is 0. Now this is 21890. This will be one remainder. So 945. So this is 0. This, sorry, this will be, I guess, 4 72. So we have a one remainder. Again, I'll be doing the same. I guess I'll be getting 236. So 0 remainder. 2180 remainder. 90 remainder. 29. So it will be 1. Please correct me if I'm doing wrong somewhere. 1 4. This will be 1 2 7. This will be 0 2 3. This will be 1 2 1 2. This will be 1. So finally we will be getting the reverse of this, like in this direction we'll be writing the final binary equivalent. So it is 111011 000 1010. Are you getting the same? I hope you are getting the same, because I've done the basic conversion only here. So now for the octal representation, what we need to do, we need to make the pairs in 3 from the right hand side. So this is 3, then sorry, then this is 3, then this is 3, then this is 3, and finally we will be getting 2 zeros extra. So these are the total 1 2 3 4 5 pairs, and we will just write the same in the octal representation, and that will give me the final octal number. So this is 0, this is 2, this is also 2, I guess. 0 0 1. So this is 1, this is 1 1 0. Is my screen visible?
No, sir.
Oh, wait, I guess I lost the connection. Give me a moment. Give me 2 minutes, I'm joining. Hmm. Is it visible now? Is it visible now? Fine, fine. So yeah, I was doing this octal conversion. So this is 6. Yes, again 6, and finally I have a 1. So this is the octal equivalent of 7562. So this is to the base 10 is equivalent to this to the base 8. Is it the answer that you are also getting, everyone? So yes, I can see the similar answer by one of the students. So similarly, you can do for hexadecimal, and this is a small number. So quickly let me know what is the answer. This is 1938. So I'm rewriting it. 1938. The base 10 is equivalent to what to the base 60. So I already have one answer, which is 792. Okay. So let's check the same. I'm doing it. I'll be getting 29. Right. So I'm getting 1 1 1 1 0 0 1 0 for hexadecimal we need to make pairs in 4. Doing the same. This is 4, this is 4, and I need to add extra 0 here. So now I can write that directly it into the hexadecimal values. So this is 0010, that is directly 2. This is 1001. This 8. This is 9, and then I have a 0111, that is 7. Yeah, so 792 to the base 16 is the answer for this. Is there any doubt? This is quite basic, I guess. I just need you to be familiar with this method of doing this, because there are various binary methods or binary problems that will be helpful to get directly converted to their octal and hexadecimal using this method. I hope you know that for the basic direct conversion, we could have gone for LCM of 8 instead of 2, and we would have got the answer directly. So just to familiarize with you one more method, I have given this binary method. So last is 175 to binary. So this is quite easy. Maybe you can do it at home. So we can skip this and we can go to this question. So again, we need to do our hexadecimal and the questions are in octal. So this is the now a good part. So from octal, you should go to binary, and from binary you can go to hexadecimal. So here you can make a pair of 3 and finally you will get a pair of 4 and you will get the answer very easily. So maybe do it in 2-3 minutes and then let me know the answer. Okay, so I've got one answer, which is option D. Let's check it quickly because now we know the efficient method. So the first is 7214 to the base 8, and we can write this in in binary very easily. So 4 is 100, then we have 001, then we have 2 which is 010, and 7 is 111. And we can directly make pair of 4 now. So this is 2. So making pair of 4 now. So this is quite straightforward. This is 1100, that is 12. This is 100, so this is 8, and this is 13. So we already know in hexadecimal A, B, C, D, E, F are there, which is 10, 11, 12, 13, 14, 15. So we have a 12, that is C, we have a 8, and then 13 is D. Uh, this is, sorry, this is 14, not 13. 8, yeah, so it is 8. So for the first answer, that is a hexadecimal for this will be E86. So option A and C are not possible. Now we need to check the similar thing for 3645. So quickly we will write it in binary 011, then 110, then 100, and 101. So now making a pair of 4. So this is again 5. This is 1010, that is 10. So I am writing directly A, and this is 111, that is 7. So 7A5 to the base 16 is for the second part, which is option D. So option D is the correct answer. Yes, yeah, yes. So option D is the correct answer. Is there any doubt? I know these topics are very basic and The questions are quite easy, but we have to follow the curriculum and we should be aware of all these concepts because this will eventually help you in solving the problems of higher magnitude also. So let's proceed then, if there is no doubt. So now there is some problems of n's complement. That is, they can ask any complement. That is, you might have heard of only ones and twos complement. These are the most basic complements for the binary numbers, and there are also like threes complement, fours complement, and so on, nines complement. So there is a proper method of doing the n's complement. That is, for any number, first of all, like here we need to calculate the nines complement. So we have, let's say, two cases. So in the first case we have 546,700. So to calculate the nines complement, we need to subtract each of the digit. Wait, we need to subtract each of this digit by whatever complement has been asked. So basically, we need to subtract each of the digit with a 9. So this is 546,700. So just by subtracting this, we will get the nines complement of this number. So that this will be 992,354. So this is very basic, I guess. Is there any doubt in this particular thing? Fine. So let me give you. Maybe you can calculate this one first. So let me know the answer to this directly, and then I'll give you a problem to solve. This is very easy. You can write directly. What one answer? I'll write whatever it is. 9, 8, then 7, then 6, then 0. Finally, we have a 1. So yeah, everyone is correct. So similarly, we can apply this concept to 16's complement maybe. So if we have, let's say, um, 7a 5 6b, and we need to find 16's complement. So quickly let me know the answer. This is also a similar question. And then maybe 1 2 5 7. So again we need to do the number subtraction. So first of all I'm writing for 16. Maybe you can calculate for this. I'll calculate the easier one and let me know the answer in the chat box. So I already have the answer. So B is, this will be 5, this will be A, this will be 11, that is B. A is 10, so this will be 6, and 16 and 7 is 9, that will be 9. I guess you all are getting the same. And similarly for this 7s, it is 6 and then 5 and then 2 and then 0 and then 1. These are like very basic. So we done a basic question like before to find the radix. So quickly let me know the answer. Maybe you can take 2 minutes now and let me know the answer to this. So I already have some answers. It's 5. So first of all, I'll quickly writing 55 to the base 7. So this will be 5 plus 35. So this is 40. So I'm writing the equation directly. Square plus 2y plus 5. This is 40. This is 35. Sorry, this is minus. So this will be plus 7 minus 5. So we can write these as r plus 7, r minus 5. So there can be only two possible value, plus 5 and minus 7. So my negative is not a possibility, and 5 is, there is no value which is greater than 5 also. So yeah, there is only one possibility, it is option C. I guess we can move ahead quickly because this was a similar question. Okay, so this is interesting. So we need, out of the given options, we need to find the conversion of this particular binary to its decimal equivalent such that the error is should be kept in the order of milli, that is 10 raised to power minus 3. So maybe you can try this out. You need to convert this into a binary equivalent. So these are all binary equivalents, so that the error should be in the order of milli, that is 10 raised to power minus 3. So quickly let me know the answer for this. Maybe you can take 5 minutes for this particular question and let me know the answer. Okay, so I've got one answer as C. Let's wait for one or two answers and then I'll also solve. So you need to keep in mind that you need to keep the error in the order of 10 raised to power minus 3. If the error is more, then you need to check it. Okay, it's fine. I'm getting 2. So all of you are saying C, I guess. So let's check it out. So first of all, we have a 121.6. So we'll be doing the 1 to 1 part first. That is the basic binary, or I will write directly that this is, I guess, 34, then this is 96, 96 and 16 are 102, 112, then again 8, then 4, 2 and 1. So 1 to 1 is 1111 001. So it is, oh, it is in all the options. Okay, so only option D is eliminated by the LHS directly. So we still have 3 options. So now we have a 0.6. So for option C, maybe I'll write for the first part, this is 2 raised per minus 1, and then we all have a 0. I'm using the C option that all of you are saying, so this will be 0.5. So 0.5 is, so error here will be 0.6 minus 0.5, or you can directly write 121.6 minus 121.5. So error is 0.1, that is 10 raised per minus 1. So you need to keep the error first of all below or in the order of 10 raised to power minus 3. So this is not enough first of all. So option C cannot be a possibility. We need to go to further digits also to calculate the error. So if I do the same, then all of them are 0 0 only. So after doing this, I'll get 1 times 2 raised to power minus 4. That is, I guess this is 0.25, this is 0.125, 0.0625, I guess. So this is 0.5625. So here I'll calculate the error. This is now option B. It is 0.6 minus 0.5625. I can write this as 5, then 97, then 93. So this is 3.75 10 raised to power minus 2. It is still not in the order of 10 raised to power minus 3. So I'll go for one more iteration, that is the last option A. Maybe this will give me the final answer. So this is 0.5265 plus 0.0625 by 2, 0.5625 plus point. So I'm writing it the final answer. 9 into a 3, 3 and this and 9. So now I'll calculate the error again. So the error is zero point 0.6 minus this number 0.59375, that is 52600, which is 6.25 10 raised to power minus 3, which is in the order of 10 raised to power minus 3. Is the intention behind the question clear? We need to have the error in the order of 10 raised to power minus 3. And all of these B and C are not doing the same. Option B was giving an error of 10 raised to power minus 1. Option B was giving in 10 raised to power minus 2. So that's why we went till option C, that is 10 raised to power minus 3. Is it clear, everyone? So option A will be the correct answer. Any doubts in this? Any doubts? Okay, fine. So this is a question of basic conversion in which we need to convert this decimal to its binary equivalent such that the error should be in the order of 10 raised to power minus 3. The error should not be higher or lower than that. It should not either be higher or lower than 10 raised to power minus 3. So all of you as said option C. First of all, we converted this as 1 to 1.6. So the 1 to 1 part was always correct for option ABC, that is 4 times 1 0 0 1. Then we need to check the basic error will be coming out of the decimal digit, that is 6. So zero point 0.6 was a decimal digit, and for option C we had 0.100. So zero point 0.1 is 1 times 2 raised to power minus 1. This will give me a 0.5. So the error between both these numbers, that is a subtraction, the number I have written here is 121.6 minus 121.5. This will give me an error of 0.1, that is 10 raised to power minus 1. This part is clear? Whosoever has asked. So that is why I went to more options, so that the error should be in the order of 10 raised to power minus 3, which is given in the question. So even if I add one more one, that is option B, it was coming out to be 0.0375. I can write this as 3.75 times 10 raised to power minus 2. So still the error was higher on the higher side, that is 10 raised to power minus 2. So that is why I still went for one more option, that is option A, and I still add one more digit, which was giving me this final answer, that is 1 to 1 point this thing, and I calculated the final error, and it came out to be 6.25 times 10 raised to power minus 3, which is in the order of 10 raised to power minus 3. So that is why I gave the answer as option A. Is it clear now? Fine. So let's move ahead. Fine. So this is a basic conversion. So quickly let me know the answer to this. You can take 1 or 2 minutes. I have already told you the technique to this. So I've got one answer as option D. Okay, we can wait for 1 minute and then I'll also solve. So I've got some different answer also option B. Let's try to solve it. I already told you you need to just make the pairs. So 6 is what is 6? 0 1 1 0. Then we have a is 10, so it is 1 0 1 0. Then we have a e which is 14, so it is 1 1 1 0. Then we have a d which is 13, so it is 1 0 1 1, I guess. Okay, so making a pair, so this is sorry 1 0 1 1, and again I'll write this d to c directly. So d is again 13, so 1 0 1 1. Sorry, d is this is not 1 0 1 1, this is 1 1 0 1. So also here it will be 1 1 0 1. Then we have a 2 which is 0 0 1 0, and finally we have a c which is c is 12 1 1 0 0. So now we just need to make the pairs that we generally make, that is already there. Here we need to see there is no need of this 0, and here also. So yeah, one thing you need to remember here is as you can see, I guess both the options are present. 1 1 0 1 0 0 1 0 0. No, no, not all the options are present. You are saying option D. Option D, A, B, C, D, 11, 10, 11, 12, 13. Hmm. So this is 1 1 0 1 0 0 1 0 and 1 1. So ultimately you also don't need these two digits. So I'm not sure. Why are you getting option D first of all? Anyone who is getting option D, can you explain why D? I'm not getting it. Is there some error from your side? So I'm getting 1 1 0 1 0 1 0 1, and then 1 1 1 0 1 1 0 1 0 1. Yeah, so I'm getting option A. Uh, and no one has written option A. Yeah, so now someone is in A. So is it the error from your side?
Sir,
Sorry,
sir, what you
you're not audible clearly. Can you speak a bit louder?
sir, option A is correct.
Yeah, option A is correct. Yeah, thank you. So option A is the correct answer. This is a basic like binary conversion. So I hope it is clear. Let's move ahead. Okay, so now it is a question which says a decimal number is this, which is converted to a binary number. So this is a similar question as we did in the previous one. You need to just let me know the answer of this m and n. So what will be? It will be either 0 or 1. So quickly let me know the answer and do it quickly. Try to do it quickly as you can. Okay, so we can wait for one or two answers. I've got one as D, so we'll see. I guess D cannot be the answer. Maybe you can recheck your answer. I think by seeing the options, D cannot fulfill. Okay, so I've got one more answer as A. Let's try it now. So this is a very basic conversion, which is 23.6 to the base 10 is given. So 23 in decimal will be 16 plus 4 plus 2 plus 1, I guess. So this is 10111 point something will be there. So we can clearly see it is 1011 M is given. So M will clearly be 1. So it will be either A or either D. So now we have a 0.6 in the decimal. So even for 0.6 I will be requiring 0.5 because it is 0.6 is greater than 0.5. So I will be starting with 1 times 2 raised power minus 1, then it is given 0 plus 0, then this is minus 1 2 3 4, then 5. This will give me 0.5. This will give me 0.0625. This will give me point, I guess, 0.3125. And on adding them I'll be getting 0 point something, 0.59, I guess. 375, I guess. I'm not sure, but this is 23.59375, which is the uh, almost equivalent to 23.6. So I will have to require at least zero point 0.5 to get that. So just by looking at the option, that is why I said ki n equals to 0 is not a possibility to whosoever has written D. So I need to have n as 1, and m is also calculated as 1. So yeah, option A will be the correct answer. Is there any doubt in this option A? Yeah, so option A, whosoever is written, is correct. Any doubts in this? Fine. Okay, so now this is a decimal conversion. So the basic method will be, so this is division and multiplication. So the basic method will be convert each of them to decimal and then find the final answer, because the binary division and multiplication is not straightforward. So try to do that and let me know the answer. This is very easy, basic. Okay, so just to clarify, so this is something divided by something, and this is in the numerator, the multiplication part. It is not, the whole part is in, not in the denominator. So this is like x divided by y times z. So this is x, this is y, this is z. Yes, still no answer. So let me try to solve it then. So this is, so I'm writing the x first of all, which is 1100.011. This is 0.25, this is 0.125, 3, 7, 1, 2, 4, 8, 16 plus 8. So x is 24.375. Similarly, let's calculate pi, which is 1100. So 2, 3, 4 plus. So this is 12. This is 0, 0, 2, 0.125, 0.0625. So this is 0.1875. So y is 12.1875, and finally z is 2, 3, 4, 16 plus 32, that is 48, and 0.5 plus 75. So finally I have 24.375 by 12.1875 times 48.75. Okay, this is approximately 2. So 2 times 48.75, or maybe 2 times 48 is 96. So answer will be near 90. Yeah, there is one option. So let's exactly calculate. I've done the calculation, so I'm calculating this part. This is 24.375 multiplied by 48.75. So I'm getting exactly 97.5, which is, I guess, option D. So why does it take so much time? Is it clear, everyone? This particular question, this was basic maths. I don't know. Is it clear, or is there any doubt in this? Please respond if it is clear. Okay, so let's move ahead. Okay, so now this is a interesting question. This will cover one more concept, which is, I guess, one's complement and two's complement. So we need to compute a and b in the following expression. That is, it is given in octal, and we need to find it the value of a, that is in the similar ways, that is base 8, and we need to convert it to again to its hexadecimal equivalent. So maybe you can try this and let me know. Maybe you can take 1 or 2 minutes, and then I'll let you know how to do it. So octal to hexadecimal, this is quite easy. If you do it in the direct method, then I'll let you know one more method which can be used, which will be helpful in further questions also. That is ones and twos complement method. So first of all, let me know the answer of this question. Okay, so I already have an answer, which is option B. Maybe you can take 1 more minutes. Anyone else? So let me try to calculate. So for this, you need to know that x minus y is nothing but x plus 2's complement of y if both are in binary. So if you need to subtract two numbers, you need to convert the latter number into the 2's complement, and you can just add that number to the first number and you will get the final answer. So I'll use this technique in this to particularly solve this question. So in this, x is 3357 to the base 8, and we already know the conversion part now. So 011 011, and then what is this, 5 101 and 111. Y is 1772 to the base 8, so 1 is 001 11 010. So now to convert a number into 2's complement, so we have a method. We convert it into a 1's complement, and then we add 1 to that number, and that will give us the 2's complement. And 1's complement is nothing but the complement of the number, direct complement. So I'll let you know if it is getting complex, so just bear with me. So this is y is 001 111 111 010. So 1's complement of y will be just the opposite of this. So this will be 110 000 000 and then 101. uh, is there any doubt in 1's complement? Please let me know if there is any doubt. Anyone, is there any doubt? Please respond. Should I repeat? Please respond, guys. This is important concept. This is one of the topic of this week's. Any response? So I'm assuming that you have understood then. So if you add 1 in the 1's complement, it will give you the 2's complement. So 1 is just 0 1, then it will remain 0. And finally, what you need to do is you need to add the final number to x. So I'm doing the same now. So x is 0 1 1 0 1 1. I'll just add this. This will give me the final answer. So this is 1 0 1 1. So we can neglect if we are getting an additional one. This will be the final answer, and we need to convert it to its octal equivalent now. So which is 101 110. Then we have this. Then we have this. So this is basically 1. Then we have a 3. Then we have a 6, and then we have a 5. So option, oh, so we need to convert it to hexadecimal also. So A and C cannot be the answer. So I'm directly doing it now by taking a pair of 4. So this is 0 1 0 1 1 1 1 1, and then finally 0 0 1 0. So this is 2, this is F, this is 5. So 2F5 to the base 16. Yeah, so option B is the correct answer. So let me like give a very basic example for 1's complement if you don't understand. So let's say I have a 5 which is 101. So 1's complement will be 0 1 0, and 2's complement will be 0 1 0 plus 1, that is 0 1 1. So this is the 2's complement, this is the 1's complement. Just a basic example. So the final answer is option B. Is there any doubt? Fine, then let's proceed ahead. So now we have a full adder question. So it says a 1 bit full adder. Is my screen visible? Okay, fine. Give me 1 minute again then. Is it visible now? Please quickly respond if it is okay. Fine. So we have a 1 bit full adder, uh, which takes 90 seconds to produce the sum and 30 nanoseconds. Sorry, it is nanoseconds. Uh, what is no? Uh, is my screen not visible? Okay, fine, fine. And 30 seconds to produce the carry. So if an 8-bit parallel adder, so parallel means parallelly we are using 8 full adders, is designed with a full adder block, what will be the minimum propagation delay? So this is like a theoretical question, so you can just remember the formula for these types of questions. So the minimum propagation delay will be given by sum propagation delay. I am writing this is tau sum plus whatever the number of parallel gates are used times carry generation delay. So here it is 90 plus 8 minus 1 times the carry generation delay is 30, which is 90 plus 7 times 30, which is I guess 90 plus 210. This is 300 nanoseconds, which is option D. So minimum propagation delay is some propagation delay because it is okay. So it is used one time because we can do the sum in parallel in a single pulse, and carry will get generated by each and every previous carry. So that is why n minus 1 carry generation delay. So this is how it for this formula comes, and it is sum plus n minus 1 times carry, and it is 300. Okay, fine. Now we have half adders. Okay, so in this circuit we have two half adders, and we need to find the value of S2 and sorry, yeah, C2. So just to clarify, half adder, we have two blocks, that is sum and carry. That is why it is written as S and C. So the sum of half adder is given by, I guess you already know, A XOR B, and carry is given by AB. So you need to find here the value of S2 and C2. So you can take maybe 2 minutes and let me know the answer. This is very basic, and let me know the answer in 2 minutes. Okay, so I've already got a D. So let's calculate. This is very easy, I guess. I have A, B here. So S1 will be A XOR B and C1 will be AB. And both are getting the same input as the AND combination of both of them. So let me, so AND of them will be, maybe I can write input to the second half adder is A XOR B times AB, which will be A B complement plus A complement B times AB. So it will be, okay, so 0 plus 0 and, oh yeah. So both of them are getting a 0 input by the AND operation. So finally S2 will be 0 XOR 0 and C2 will be 0 times 0. So this is 0 and this is 0. So option D will be correct. So yeah, option D is the correct answer. Is there any doubt in this? Anyone, any doubt? Fine then. Okay, so you need to now calculate ones and twos complement of these numbers. So let's say first, second, third. So quickly let me know the twos complement, or maybe I can also do it simultaneously. So you can also do it. I have already told you the concept. So first part is 1 1 0 1 0 1 1 0 1 0, sorry, 1 0 1. So one's complement I'm writing directly 0 0 1 0 1 0 1 0. Two's complement will be plus one of that. So this is two's complement. So this is the first part. Similarly, the second part is 1 0 1 0 1 0 1 0. So one's complement will be 0 1 0 1 0 1 0 1, and two's complement will be 1 0 0 1. So this is the two's complement. Is it clear, everyone? This is quite easy, I guess. Any doubts in this? Any doubts? If there is no doubt, then quickly let me know the answer to the third part very quickly. Don't take much time. Okay. So once is I've got 0 1 1 0 1 0 1 0. This will be the 1, and second will be 0 1 0 1 1. This is 1, sorry, and this is 2's. I hope it is clear now. Similarly, you have a question. As I told you the technique, so x minus y will be x plus 2's complement of y. Y minus x will be y plus 2's complement of x. This is a similar question. You can note it as a homework problem for the next week. Please note the question, the value of x and y. If noted, please type in a chat box quickly. Have you noted it? Okay, fine. So yeah, one important announcement that next week instead of Tuesday, I'll be taking the class on Friday this week only. Like after 3 days, there will be one more class for the next week, whatever the topics will be. I'll be starting the week with this question, the two's complement method of this particular question, and then with the subsequent topic of week 6. So instead of meeting on the next Tuesday, we will be meeting on this Friday only. I guess that is 1st of March. I'm not sure about the date, so you can check that. So yeah, that is the announcement, and for now we can dismiss the lecture and we'll meet in the subsequent week. Is it fine? Any doubts, anyone? Any doubts? Fine, then thank you everyone. We will meet in the next week now.